like, basically what I'm going to help you guys with is a problem like this.
I'm pretty sure everyone here has been through pre-calc or is in trig, so they should know the context of this.
Okay.
Just long division of polynomials.
Yeah, long division of polynomials. It sounds really complicated, but it's not too complicated. So, trying to divide 3x cubed plus 4x squared minus 2x minus 1 by x plus 4. So, I would write it like so. X plus 4 under the... I always called this a house, because that's how I learned it in elementary school.
Yeah.
I don't know why there's a curve in the...
I don't know, it works.
Yeah.
Wall curve.
And I know a lot of people use the rectangle, the generic rectangle backwards. So don't get too thrown by this way of doing it.
Yeah.
I do it this way too.
Yeah. Okay, so then we're trying to figure out, so how many times does x plus 4 go into 3x cubed? Well, we can figure out how many times x goes into it. And x goes into it 3x squared times. So 3. And so 3x squared times x equals 3x cubed. And then 3x squared times 4 gets me 12x squared, right? And so then we subtract all this. So those cancel, and then I'm left with a negative 8x squared. And then how many times does x go into negative 8x squared? That goes into it negative 8x times. So minus 8x times, so minus 8x squared. Bring that down.
Cesar, Julio, please come to the main office.
8x times
Cesar, Julio,
4x.
please come to the main office. Thank you.
32.
Yeah, negative 32.
Okay.
And keep in mind the distributive property here. He's subtracting a negative, so it's going to be adding.
Yeah.
I think. Right?
Wait, no. I have to add all this to cancel out the
Fair enough.
8x.
Yeah, you're right.
So then that leaves me with...
Wouldn't that be a 32x?
That is 32x, thank you. I was missing that. So then that's 30... no, yes.
Yeah, that's good.
30x.
That's good.
Then, so x goes into 30x 30 times. 30 times 30x, so that's going to subtract 30x. And then 30 times 4, we're going to also be subtracting 30 times 4, which is 120. So those cancel out, and we're left with a remainder of 121, negative 121. Okay, so that's, and then of course if you were writing out the quotient of this, you would call that, it would be 3x squared minus 8x plus 30, and then that minus 121 over x plus 4. So that's how remainders are written.
So that means there would be an asymptote at x equals negative 4.
Yes. Yeah, and but another way to write this is using synthetic division, which basically does all the same processes, but it's much quicker and it's just a bunch of mental math. So the way you format it
No, because he was subtracting it.
is you would take the negative form of this. So instead of positive 4, be a negative 4. Then you would write in what you're what is being divided. So it'd be 3.
Just the coefficients.
Yeah, just the coefficients of all of them. So 3, 4, negative 2, negative 1. So I'm just going to show you what goes on. You just drop the 3 down. You multiply the negative 4 and by the bottom here, so negative 4 times 3, that gets me negative 12. You add the coefficient to this, so that gets me negative 8. Oh my goodness, what did I do to the marker? Okay.
Sorry,
Negative
folks at
8.
home.
Negative 8, then negative 4 times negative 8 gets me 32. Do some more addition, and you get 30 here. And then negative 4 times 30 is negative 120. And do some addition, negative 121.
So again.
So these, if you look closely, are the coefficients of our quotient that we came out with in long division. Basically, if you have a number right here, on the very last one, you would have, this is the remainder, right? Then this would be our normal term, our x to the 0 term, which is just 30. There's no need to write x. Then this would be our negative x term and our x squared term. And then that minus the 121 over x plus 4. And as you can see, you were just, this is just a different way of formatting exactly what you're doing over here. Because when we were over here, we would multiply 3x squared, the coefficient here, 3 times the 4 to get 12. Excuse me. And now the problem is we'd have to be using negative over here because we're doing subtraction over here and trying to cancel everything out. And one thing that's really useful is when you're doing all this, like if the question is asking for what is the limit of this function as x approaches negative 4. Right? So if that would mean we would either have a whole or an asymptote. And if there was no remainder and x plus 4 divided evenly into that equation, then it would be a whole, and you could actually find the limit. Whereas if in this case it has a remainder and it doesn't perfectly divide into it, you could say that it is going to be an asymptote, and you can't actually find the limit. You could find a limit, say, from one side or the other, but the limit doesn't exist. And that's one really useful way to use this. I'm going to do one more example, and it's going to make this even more useful. The only reason we can do this in such a short fashion is because we can just assume that the coefficient on the x here is 1. I'm going to show you how to do that for any coefficient on x. So let's see if I can find a good enough example. Oh, I probably should have just left the pointer there.
Probably.
Where is it? Oh yeah, I really like, which example? I'll do this one, okay. I'm gonna switch it up, go purple. Okay, so the question now is to simplify this equation. So if that 3 wasn't there, we could just easily set it up, and we would just have a 2 up in the top left of our little thing here, right? But that is preventing us from doing it because in order to do that, we'd have to assume that the coefficient on x is 1. So let's make the coefficient on x 1. So let's simplify that, or well, desimplify that. Let's factor out the 3.
Rewrite it.
3 times x minus 2/3. That's equal to 3x minus 2, right? You're just factoring out the 3.
Factor out 3, yeah.
So now we can just ignore that 3 for now. We'll save that for later. But we can work with negative 2/3, which is now positive 2/3. And I'll write the coefficients, 6, negative 19, positive 28, and negative 12. Okay? And then we follow the same processes. Drop the 6 down, sorry, then 6 times 2/3, that gets us 12/3, which is 4. Then negative 19 plus 4 gets us negative 15. Negative 15 times 2/3 is, oh, goodness, that's, oh, so negative 15 times 2, that's negative 30, negative 30 over 3, so that's negative 10, right? Yeah,
Yep.
negative 10. Then 28 minus 10 is going to get us 18. 2/3 times 18, 2 times 18 is 36. 36 divided by 3 is, wait, no, I'm an idiot. What is going on? No?
23 plus,
Oh, yeah, that's right. So 36, then divided by 3.
So
Okay,
it's gonna
then
be
divided by
12.
3 is then 12. And then this all cancels out, and we have a remainder of 0. So now what we want to do is, we'd want to write this. We'd just keep all the normal rules that we'd do, right? But we still have that 3 on the bottom.
right.
Because all we did
still divided by three.
was cancel this part out, but we still have a 3 on the bottom of all that. Okay? So we divide all the coefficients by 3. So that makes this, sorry, I wrote the wrong powers here, I believe.
Yeah.
Yep,
Yeah.
there we go.
So then we just divide all the coefficients by 3. So 6x then becomes 2x squared. Not 2x to the z power. Then it would be 5 minus 5x plus 6.
That's what my calculator does.
Hooray!
And then that is going to be the simplified version of math.
Yeah.
So that's how you do synthetic division with a higher coefficient on x. You just have to factor out the coefficient and then divide by it later. Or sometimes it may be useful just to divide by the 3 first.
First, yeah.
But in this case, I don't know how much it would really help us.
Yeah, 19 would be a little funky with the 3.
Yeah, dividing 19 by 3, it's not super useful, but
Everything else would have.
Yeah.
yeah. Yeah, there's one example I have on here that would be perfect. Like everything's divisible by 10, and then it's like
Yeah,
over
just-
10r minus 10.
Yeah, just chop it off.
Yeah. So I think that's all I have for synthetic division.
That's cool though. I've only ever seen long division for one x with a coefficient of 1, so that's cool. We can
Yeah, I was thinking
expand it.
that's sort of useful, but then it's limited. So I figured finding a way to do it differently.
That's cool.
Yeah.
And I encourage anybody who wants to do something like this, do your own research and stuff like that. Try to figure out how something works, get inside it.
Yeah, like I found that little trick for 11 through 19, but the guy didn't explain how it worked. And he's like, oh, go to this link and it'll explain it. And it was a broken link. So
Yeah.
I was left with just
Figure it out.
a pencil and a paper.
Yeah.
And I figured it out.
Graph paper.
Yeah, graph paper. Because
There
you
we
can't do
go.
math on anything else.
Of course not.
Well, you can do polar graph. That's still graph paper.
Oh boy.
So yeah, that's all I got.
This is done.